So summative 5 has 5.1, which is, let me find my pen. That's not it. 5.1 is just simplifying basic trig identities. And I didn't really put any on here. There was a delta math assigned on this. We did worksheets 1 through 5 on this in your packet. But at the top of 5B, there were 3 questions we skipped that I was going to go back and do now. Okay. So this is at the top of 5B. If you could just go back and finish these. Any ideas on how to simplify this one that says cosecant minus sine over cosecant? Yes. Say that again. You could split it up, yes. You could make it cosecant of theta over cosecant minus sine of theta over cosecant of theta. Now, that only works when you have a single denominator, okay? If you have an expression in the denominator, that doesn't work. I mean, it could, you could separate it with that expression, but students get really confused when there's an expression in the denominator. I can show this one another way too, if this is not the way you would have done it. What is cosecant over cosecant going to become? Okay. And then, does anybody know what cosecant is? What we could trade? Yeah, it's 1 over sine. So what happens when you divide sine by 1 over sine? The bottom flips over, right? So it becomes times sine theta over 1. Is everybody okay? And then that will become what? 1 minus sine squared. Now, we're down to only one function, but usually the answer for a identity question is not an expression, meaning it doesn't have a plus or minus in it. Is there something we could trade a 1 minus sine squared for? Yes, there was a Pythagorean identity that sine squared plus cosine squared equals 1. So if we subtracted the sine squared over here, we could trade 1 minus sine squared for a cosine squared. And that, I think, is what they were looking for. Okay. If you had started by putting everything in terms, this is just another way you could have done it. If you had started by putting everything in terms of sine, or in terms of sine or cosine, it just turns out that they're all sine. You could have chosen to multiply top and bottom by sine theta all the way through, or you could have said this top is being divided by 1 over sine, which means it's multiplied by sine over 1. And then when you distributed that, sine times 1 over sine would have been 1. Sine times sine would have been sine squared. So you would have gotten the same thing, hopefully. So just some different approaches that should have gotten you the same answer. Number 2, you want to go for sines and cosines, or is I looking at this thinking there might be a trade, cosecant squared minus 1? So on your sheet, what does it actually say? Like that? Okay. So cosecant squared minus 1 would be cotangent squared. That seems good. Okay. Cotangent squared of theta over cosecant squared of theta. Well, that helped us get rid of the expression, but now what can we do to make this simplify? What would you try next? Okay, so cotangent squared is 1 over tangent squared, but usually we trade things to sines and cosines. So cotangent is cosine over sine. So it would be cosine squared over sine squared. And that is being divided by a cosecant squared, which is a 1 over what? Sine squared. And when you divide fractions, you multiply by the reciprocal. So it all simplifies to a cosine squared. Did everybody get that? You try number 4 real quick. I think if you just change everything to sines and cosines. If you don't have those trades memorized, tomorrow's not going to go well. So please work on them tonight, okay? So for number 4, tangent would be sine over cosine. Secant would be 1 over cosine times sine. Oh, lovely. Nothing cancels, right? What do we end up with? Yep, if we multiply across the top, we get a sine squared. If we multiply across the bottom, we get a cosine squared. Why was that helpful? What is a sine squared over a cosine squared? Yep. It is a tangent squared, so we're down to a single function. Okay? This is really the same as 5.2 in terms of 5.2 is identities, where you have to simplify something where I've already told you what it's supposed to equal. All right, these 2 questions that I put on your review sheet are very, very similar to questions that are on the quiz, okay? One or both. Like one version might have something like this and the other version might have something like this, or I don't remember. But what do you have to do with this one before you can get it to become a 2 secant squared? What are we going to have to do when we have adding fractions? Yeah, we're going to have to get a common denominator. I'll try not to be too picky about how you show that, but I'm going to show it that this one, 1 over 1 plus sign, would need to multiply by a 1 minus sign over a 1 minus sign. And I'll leave out the x's for a little space here. And then that would be multiplied by the 1 over 1 plus sign that's already there. And then this fraction already has a 1 minus sign in the denominator, so it would need to multiply by a 1 plus sign over 1 plus sign. I don't know, I have parentheses in random places, I'm sorry. All right, so what happens on these first 2? When I multiply this together on the top, I get a 1 minus sine of x. Can I combine them into a single fraction? Is that okay with you guys now? Because I know they're going to have a common denominator of 1 minus sine times 1 plus sine. In any order that you want to multiply those. What happens over here? So I have a 1 minus sine of x times 1 is just a 1 minus sine of x plus 1 plus sine of x. Is everybody okay? I can do an easier example without trig functions if we need to, but you're just getting a common denominator. Once you have that, you can add the top and keep the bottom. Well, what happens when we add the top? Yep, we just have what? 1 plus 1 is 2, yes? But if you look at the answer, were we looking for a 2? Okay, we're supposed to get this equal to a 2 secant squared, so that's helpful. All right, on the denominator, I think we need to FOIL that together because I think we'll be able to use a trig trade then, right? So if we FOIL that together, 1 times 1 is 1, 1 times positive sine of x. In the middle here, we get a negative sine of x. And a negative sine of x times a sine of x is a negative sine squared of x. And if you didn't show all those steps because you know these two are going to disappear, I would really be okay with that. Yep, it's 2 over 1 minus sine squared. Okay, then what is a 1 minus sine squared? Well, we had an identity that said sine squared plus cosine squared equals 1. If we subtract the sine squared over here, 1 minus sine squared is a cosine squared. So we have a 2 over cosine squared. Is that the same as a 2 secant squared? Because a 1 over cosine is a what? Yep, so this is a 2 secant squared. So it's equal to what was on the right-hand side way up above. Bottom line, guys, you know where you're trying to get, right? So you just got to fill in steps along the way. And I have to be able to see that you clearly understood what was going on. You know, if you skipped a little bit in here and just did the trades, I would be okay with that, but I gotta see some work in between. All right, I don't have a lot of room for this one, but I'm hoping we can squeeze it in here. We can work with either side, but I'm thinking we should work to get rid of the addition on the left to make it a multiplication. That seems easier to me than trying to make a multiplication into a random addition. You want to do sines and cosines? So this one, tangent is sine x over cosine x. Cotangent would be what? Cosine over sine. This is not going anywhere nice. I think we need a common denominator, right? So we would need to multiply this one by a sine x over sine x. And this guy over here had a cosine x over a sine x. For the common denominator to have a sine and a cosine, it's going to multiply by a cosine over cosine. Sorry, I started to write that wrong. All right, so the common denominator was cosine times sine. So this first one already had a cosine, so I multiplied it by a sine. The second one already had a sine in the denominator, so I multiplied it by a cosine. Well, what happens up top? Sine times sine is sine squared, plus cosine times cosine is cosine squared. The denominator has a sine x and a cosine x in any order. What does the top become? Sine squared plus cosine squared is 1. Is that the same as a 1 over sine times a 1 over cosine, guys? And what did they want us to, I don't know if I have them in the right order, but wasn't it like cosecant times secant? Is that what they wanted, or was it secant times the right-hand side? Yeah, I don't have the order right, but I wouldn't count that. That's fine. Multiply in any order, so we ended up with what they wanted us to have on the right-hand side. I don't know these are helpful in that you know where you're trying to get, but they're often more complicated than the simplify ones. Now, I did 2 examples where you had to have a common denominator. You have 2 problems to do tomorrow, and they don't both have necessarily have to get a common denominator, okay? I have a bunch of extra practice in here. Worksheet 6B, I think you had to do any 5, okay? We can go through and do some of these, but do you want me to move on and talk about the rest of the things first, and then we can come back and do some more verifying of identities if we have time? All right, so I will skip down. The next section says is 5.3a. It says these were all the places that you practiced this. And then I put 7, it says 7, is it 7? Examples on the back, okay? Do you want to go to those now? They look like this. This says extra practice on 5.3. This is on the back. I think I'm going to go a little quickly through these because there's a lot of different kinds and I want to have time to get through them. So this first one just has a cosine. There's no cosine squared. So you want to isolate that cosine. So I'm going to subtract this one over to the other side. And 3 cosine minus 1 cosine would be 2 cosine theta equals square root of 2. Then if I divide by 2 so that I have isolated the cosine function, it says the cosine is square root of 2 over 2. Then you take your unit circle and you have to read directions carefully. This says only the answers between 0 and 2 pi. So I think there are 2 places that that's true. Maybe pi over 4 and 7 pi over 4. Is that the other one? Okay. So theta equals, and you don't have to have the theta equals, but either of those 2 places. If it had said all solutions, what would you have to put on the back of each of those? Plus or minus 2 pi n, okay? But you don't have to do that here. So on the next one, I might add 2 sine x over to the other side. You could make it equal to 0. You just have to solve it however order you want to do it in, but 4 sine x plus 2 sine x would be 6 sine x. And then I'm dividing by 6, so I end up with 1/2 equals sine of x. And what 2 places is that true? Make sure you're looking for the 1/2 back in the y spot for sine. Okay, pi over 6 and 5 pi over 6. Everybody okay? All right, so those were the kind where you're just isolating because there's no squared or anything funky like that. These 2 questions, you have to factor, but before you can factor anything, what does it have to equal? 0. Okay, remember the take your turn being equal to 0. It only works when it's equal to 0. So somebody's going to look at number 4 and factor out a cosine of x, but you can't do that, okay? It has to equal 0 before you can factor it. So number 3 is already is already equal to 0, sorry. You can look at this as maybe a 2, I'm going to use m today, I guess, plus 5m minus 3, okay? So it's 2 something squared plus 5 something minus 3, and you need to figure out how that factors. How are we going to get a 5 in the middle, guys? I'll just do it with m's down here and then I'll erase it. But 2 m, right? To get a 2m squared, we'd need a 2m and an m. And to get a 3, you got to have a 3 and a 1. Any ideas? I'm thinking the 3 has to go there so that we get a 6. And a 1. and we want a positive 5, so we have a plus 6 and a minus 1. Okay, does that give me 2m squared plus 6 minus 1 would be plus 5 and a minus 3, okay? So we figured out how it factors, but then instead of m, what are we going to go back and write in there? Sine of theta. All right, and then it's equal to 0, so we need each of those to be set equal to 0. 2 sine of theta minus 1 equals 0, or sine of theta plus 3 equals 0. When we isolate the sign here, we'd have 1/2. We isolate the sign here, we'd have negative 3. Are the directions still the same for these two questions? Okay, so still just 0 to 2 pi. Anywhere that the sign equals negative 3? No, that one's garbage. Sine is 1/2. Didn't we just do that one? Is it? We're looking for the sign, so it's got to be in the y spot. Pi over 6 and 5 pi over 6. Okay. Now, what about number 4? What did we say had to happen first? Yes, so if we add the 0 over to this other side so that it's equal to 0, I get cosine squared minus 2 cosine plus 1. All right, again, if that said m squared minus 2m plus 1, we'd have an m and an m. Sounds good. I'm in a chocolate mood. Okay, we got a 1 at the back. How are we going to get a minus 2 in the middle? Minus 1 and minus 1? Does that work? So it's going to be cosine of x minus 1 times cosine of x minus 1 equals 0. If you foiled that back, you'd get a cosine squared minus 1 cosine minus another 1 cosine, which combined to be minus 2 cosine, and then a plus 1. If we set that equal to 0, we can do it twice, but it's the same factor, right? We get the cosine of x is 1. Isn't that only one place that happens? It is called 2 pi, but I got to look at the directions. I can't get it. Oh, I got it. It's on a different slide. I'm trying to scroll up. It says square bracket 0, 2 pi, parenthesis. So we're not supposed to include 2 pi, so we would need to call it what? 0. Because that same place on the unit circle is called both 0 and 2 pi. All right. Then there are two that say all solutions. Okay. All solution means we have to remember to put plus or minus 2 pi n on the back. All right, so what can we do to this one? It's already equal to 0 and there's no squared. Yeah, we have to take out a common factor here. We did a lot of these on the homework, but I only see one here. But take a tangent out of both this term and this term. So if we factor out a tangent of x, we divided it out here, so we'll have 2 sine x. And we divided it out here, so we'd have a minus square root of 3. So then we're already ready to set each one equal to 0. We would get the tangent of x equals 0, or 2 sine x minus square root of 3 equals 0, which would be sine x equals square root of 3 over 2. I kind of skipped a step there. Is everybody okay? It wants all solutions. And remember, tangent isn't going to be written on your reference sheet for you, but tangent is y over x. So I'm thinking the only place that there's zeros in the y, the x is plus or minus 1, so we need both of those spots, which would be 0 and pi. Did I do that right? And then you can put plus or minus 2 pi n on the back. Now, that one especially, because the period for tangent is really just pi. You could have just said 0 plus or minus pi n. That's a little shorter way to write it because it's 0, then you go pi more and you find 1, pi more and you find 1. Okay, that's just a shorter way. If you wrote the longer way, I'm not going to count it wrong. And then the 2 for sine to be square root of 3 over 2, that would be back here, a square root of 3 over 2. So a pi over 6? No, pi over 3. Pi over 3 and 2 pi over 3, is that right? And then all of those still need a plus or minus 2 pi n. Questions? Is this number 6 the same question we did earlier? No, I guess not. This one would factor 2 cosine and 1 cosine. And to get a 5 with a 3, I think we need a 5 here and a 1 here. Is that working, guys? 2 cosine and 5 cosine. We need the 5 cosine to be negative so that we end up with negative 3 cosine in the middle. All right, so we'd have 2 cosine equals 5 and cosine equals negative 1. I'm kind of skipping steps here because I'm worried about time all of a sudden. 5 halves is 2.5. Remember, the cosine only goes up to 1 and down to negative 1. So this one is garbage. The cosine is negative 1 only at pi, isn't it? So you'd say pi plus or minus 2 pi n. Is there a number 7? I don't have it. So what does it say? I guess I... Can you read it?
Yeah, square root 2 cosine x sine x minus cosine x.
Okay, so that's very messy, sorry. We could take a sine x out of both, right? What would be left? But cosine, thank you. I didn't write it correctly and then I can't solve it correctly. I'm just a hot mess. Okay, take a cosine of x out of each. What would be left? Everybody's going to remember that this has to be a minus 1 back here, right? Cosine divided by cosine. All right, so then we have the cosine of x equals 0, or the square root of 2 sine x. If I add 1 over to the other side, I get 1 over square root of 2 when I divide, which rationalizes to square root of 2 over 2, and that looks more like something that's on our unit circle, yes? So cosine is 0 means x is 0, which would be pi over 2 and 3 pi over 2. And was this all again? Yes, you could do pi over 2 plus or minus pi n, or you could actually do plus or minus pi over 2, plus or minus pi over 2n, different ways, yep. And the sine is square root of 2, I think is pi over 4 and 3 pi over 4. Did I get those both right? All right. I really need you to be good at equation solving, okay? Then if I go back, the other section of the quiz has simplifying the using identities. I don't think I have any practice on here, but for example, if you saw a question that said 2 sine for beta cosine for beta, could you find a trade for that, guys? 2 sine cosine on your peach seat, 2 sine cosine. Is it the sine of 2 theta? The double angle one? So it's the sine of 2, but instead of theta, this one had a 4b. So then you could say it's the sine of 8 beta. Do you remember doing those? Sometimes they had like numbers in there like 27 degrees and 27 degrees, okay? I just didn't put a bunch of those on here because we did quite a few for practice. But part of that section is also one of these kind of proofy things. It's very clear in the directions. It says expand to verify. So if this is the sine of a plus b, can someone read what the sine of a plus b says?
Times cosine of b plus cosine of a times sine of b.
Okay. I put in the 3 pi over 2 for the a's and the x for the b's, as she read that, yes? So this is the expand step. And then there is the substitute step. Can you flip your sheet over and tell me what the sine of 3 pi over 2 is? 1, is that right? No, 3 pi over 2 is -1. Cosine of x. And 3 pi over 2, the cosine is 0. And this is a verify question on the quiz. So you need to write out that step. And then what are you going to tell me? That goes away and we just have negative cosine of x equals negative cosine of x on the right-hand side here. Does that seem okay? I don't know why, but this is the same theorem, isn't it? Isn't it sine a plus b? It's not a theorem, it's an identity, but I used the same one twice, I guess. But the sine of 2 pi plus theta for the a and the b would be sine of 2 pi cosine of theta. I don't know why that looks like it's up in the air, sorry. It's floating. Okay, that's a mess. Sine 2 pi sine cosine theta plus cosine 2 pi sine theta. What is the sine at 2 pi? Sine is 0. And the cosine is 1, yes? And so what's left is just 1 times the sine of theta, and that is what they had up here on the right-hand side. You okay with those? Not too bad? I hope that I wrote long lines like to remind you that you have to expand it out, okay? Then there's what we did yesterday. It does look like this on the quiz. You're welcome. It's drawn in the right quadrants, okay? But you do have to finish with Pythagorean theorem. Let's see, what is these are big numbers. 20 squared plus 21 squared. Either don't worry about the negative or make sure you put it in parentheses. But you get 841, and then when you square root, I think you get 29, right? All right, so the sine of that. Now, this is confusing to some students. I wrote the alpha out here because it really is the angle all the way around to there that you're graphing, but you're using the reference angles. So don't freak out and put some weird other numbers there. Just tell me the sine of that triangle, 21 over 29, and the cosine is negative 20 over 29. Are we okay? Okay, this triangle over here, we already know the hypotenuse, so it would be x squared plus 7 squared equals 25 squared. 25 squared minus 7 squared is 24 when we do, I think we get 576. So we get 24. All right. And go back over here and fill in sine and cosine for that triangle. Sine would be opposite over hypotenuse, 7/25. And cosine would be 24/25. Did I do all those right? Okay. That's exactly what it looks like on the quiz. Okay, so I'm trying to show you where to put things so that I can give you, I can know that you did the right steps. And if you made a mistake, I can figure out where you went wrong. It says trig trade used on the quiz, and I didn't leave much room here, but that's where you actually write out the original one. What did the original one say for this? Can anybody read it to me? And I don't care if you write it out with A's and B's or alphas and betas or whatever. It says, okay, there is a blank drawn on the quiz. There's not on your review, but it says trig trade used, and that's where you draw that in, write that in, okay? Then it says show your working calculations. I forgot to say this yesterday in this class, but a whole bunch of people will write down this. Don't write this. Do you see what I'm saying? They want to put the function in for just the theta. Okay, that's not right. The whole thing is being replaced. Don't confuse yourself, okay? Don't confuse yourself. Cosine of alpha is negative 20 over 29. Then cosine of beta is 24 over 25. And then it said plus sine of alpha, which was 21 over 29, plus times sine of beta, which was 7 over 25. And you can just type all that in your calculator, and it's going to be a nasty fraction, I think, but don't forget all your parentheses. And just make it easier to understand what you're typing in. Ugh, if I could type, it would be really great. Plus in the middle, 21 over 29 and 7 over 25. Okay, meh. Is it 18279 over 145? No. I was gonna say, it doesn't seem like it should be more than one. I think I must have had something typed in. Oh wait, I see what I did. I didn't put a divide right here. I was like, that can't be right. All right. Yes. Now I got negative 333 over 725. Yes? Whew. Well, if you get a really disgusting wackadoodle answer, check what you typed, okay? But it should be a fraction. All right. And then the last one here, I think this is the last one. This one again will say draw. I don't think it gives you the drawing this time. It says here quadrant 3. So if I go over here into quadrant 3 and I drop out the hypotenuse and connect it back to the x-axis, what is secant telling us? If we flip it over, yeah, it's either hypotenuse over adjacent, or you can flip it over and say, I already know the cosine. Actually, we don't even need to draw this, but I'll go with it. Cosine is adjacent over hypotenuse. If you did Pythagorean theorem, you'd get a 3 and it would be negative because of the quadrant. Hello?
I was looking for Mr. McGovern because he had it there this hour.
This is east 125. I don't think Mr. McGovern's on this side.
Okay, thank you.
Yep. We actually didn't need to do this, because can you go look at cosine of 2? You might need to do it on the quiz, depends what it asks for, but cosine of 2a has 3 trades, right? And one of them only needs the cosine, doesn't it? I'll do the one I usually do, okay? I'll pretend I needed it. Cosine of 2a, is it cosine squared minus sine squared or sine squared? It's cosine squared first? Cosine squared minus sine squared. So if I substituted in the values, the cosine is -4/5 squared minus the sine squared. What would the sine squared be of this? Well, sine of A is -3/5. And it honestly wouldn't matter if you forgot the negative in this particular one because you're squaring it. Then you could type it in, but it should be 16/25 minus 9/25. I think you get 7/25. If it was sine of 2 theta or tangent of 2 theta, you would have had to use the whole triangle. But there's a shortcut for this one, guys. Wasn't one of the trades for cosine of 2a actually, is it 2 cosine squared minus 1? So if you had just said, well, I already know the cosine is -4/5, I could have done 2 times 16/25 minus 1, which would have been 32/25 minus 25/25, or 7/25. Look at that. And I didn't even need to draw the triangle, but you probably, I don't know that it's that way on the quiz. So, questions? All right, 2 things for extra practice. There is a Delta Math called Optional Review, but there is also in the Google Classroom, guys. Put that one away here. At the bottom of today's post, what is happening? At the bottom of today's post, I attached an extra worksheet. It's some more verifying, okay? Can everybody see up here? It's a few more verifying questions, and then here is the key with some worked out, at the end of it is a key with some worked out suggestions the way you could do it, okay? So if the verifying is freaking you out, just take a piece of paper, write these down and do them, or print it, whatever you want to do. It is in Google Classroom, okay? Any questions? Got to have your homework check ready for tomorrow, right? Anybody need an extra copy of anything?